1.1 lines in a plane. What we should learn in this lesson. So this lesson should hopefully be review. This whole first chapter will be mostly review, but let's go over it. Find the slopes of a line. Write linear equations given points on a line and their slopes. So we're going to be able to write an equation of a line given various ideas. Use slope-intercept formula of linear equations to sketch lines. So we're going to use the slope-intercept formula to help us graph. And then use to identify parallel and perpendicular lines. That's everything we should kind of go over here. So first, slope of a line. Remember, slope of a line is how slanted the line is. So it's like, and here you can see it's going up, so this is a positive slope. If it was going down, it'd be a negative slope. So we want to figure out like how slanted this is, like what incline is it? That's what a slope is. There's a couple of ways to find slope, but they all kind of start with the same way, which is first you want to find 2 points, and then you're going to do slope equation, given these 2 points, right? x1, y1, x2, y2. You find the slope of that, which is use the slope equation, y2 minus y1 over x2 minus x1. Also known as the change of y over the change of x. Sometimes you see that written like this, delta y over delta x. Delta just means change. So that's the same thing as that. The other way to do it is rise over run. So it's the exact same thing, but a lot of times you hear it say rise over run. And all that means is, so the run is like how much you went left and right. So like that's your run, this part right there. So I always think you run that way, and then you rise, you go up or down. If you have to go up, positive. If you go down, negative. Now, the key thing about that is you go from left to right. So if I was doing this, this would be my run, and this would be my rise. All right, you get the same information. It's all about how you want to do it, right? But the key is you got to find 2 points, and then either do the slope equation or do rise or run. So let's do a quick example. So we want to find the slope of these two guys. So if I have a line, I'm generally going to do rise or run. So I'm going to pick 2 points. So like let's say that point there, and let's say this point there. 2 points that cross the line so that you know what points those are. It's kind of hard on here because you don't see any other points, but I'll pick these 2. And we're just going to try to go from one to the other. So I got to go down. I went down 8. Since I went down, that's negative. And I went over 2, and then rise over run. Be negative 8, because right up and down is rise, and this or fall. And then run is 2, so I get negative 4. It's my slope. In this case, you have 2 points. If I see 2 points, I'm going to do x1, y1, x2, y2. So my slope is going to be y2 minus y1 over x2 minus x1. Substitute these values in. So I'm going to have, now keep in mind it doesn't matter which one's x2 and which one's x1. Like you could have done x2, y2, x1, y1. Just keep in mind it just has to be in order. So x1 goes with y1, x2 goes with y2. If I plug these in, negative 4, 4, 4, 2. So negative 4 minus 4. 4 minus over here, right? They're both negative. Anytime they're the same sign, you just add them. So negative 4 minus 4, negative 4 plus negative 4 is negative 8. I just get more negatives, right? Negative 4 minus 4 is 2 negatives. Anytime they're different signs, you subtract. So 4 minus 2 is just 4 minus 2, 2. And I get negative 4 again. So there we go. So that's how I find slope of a line. Now keep in mind, right, like I was talking about earlier, if the line's positive, it rises. So if you have a positive slope, your graphs kind of look like this. If it's negative, it's going to fall. Like, so our negative 4s here, they're going to go down because you're going to go down 4 and then over 1. That's not the right slope, but that's how negative works. If you get a 0 slope, I always think about slope is like, how do you walk? So this is like a positive slope. You're walking uphill, walking downhill. Slope of 0 means like on the street, like there's nothing, like there's like no resistance, even though my picture looks a little going up. Let's see. There we go. So that's the slope of 0. It's like this is like going up here, like work harder. It's going downhill, working with gravity. 0 means there's no resistance. You just straight. And then a line with the undefined slope. So it means there's no slope. You can't walk it. Well, that's a vertical line. So that's gonna look kind of like this. Show you the straight line there. So that is no slope because you can't walk up a wall. So that's what I always think about. Like, so this is like the pavement floor. Easy walk, slope of 0. No slope is you can't walk it, so it's like a wall. And then a little bonus here. These equations are generally x equals something. That's supposed to be an arrow right here, by the way. Let me cross that out. That's an equation for no slope. It's x equals, then that's where you get a vertical line. Horizontal ones are like y equals something. Y equals some number. That's how you get a horizontal line. So you might need that in the future. Okay, next, point slope form of a line. Point slope form, I like to call this my equation maker. I use this to make equations. It's the easiest thing to make an equation. So point slope is exactly what it sounds like. It has a point and it has a slope. So you can see right here, right? Here's my slope. And then your point is the x1 and the y1. That's your point. X and y are just part of the equation. When you get any equations with an x and y, you don't fill those out. What you do fill out for is x1, x1, y1, and m. So let's do a quick example. In this exercise, find the equation of a line that passes through the given point and has an indicated slope. So this is the easiest version you're going to get ever. Where you go, okay, I want to make an equation. Anytime I want to make an equation, for me, generally, you want to use point slope form. So we're going to do y minus y1 equals m x minus x1. And then we're just going to plug in our values, substitute in our values. So this is x1, y1, and this is my m. So m goes there, negative 3 goes there, 6 goes there. You get y minus 6 equals negative 2 x. Now again, double negative, 2 negatives make a positive, x plus 3. And you're done. Unless they specifically say put it in like slope-intercept form, which technically we haven't talked about yet, that's it. If they say make an equation of a line, there you go. Now there's more stuff here I want to sketch by hand. We'll do that later. But that's an equation of a line. So next, sketching graphs lines. So when you want to sketch a graph of a line, that's when we're going to use slope-intercept form. That's best for graphing. So slope-intercept form is my grapher. So when you want to graph, you want to do slope-intercept form. Okay, so in that, because it tells you everything you need to graph, it gives you your slope, right? Remember, m is slope, which is just rise over run, delta y over delta x. And then b is a y-intercept, which is exactly what it sounds like. It's your first point. It's where you start. Let's do a couple real quick. Now, this one, if you notice, it's not in slope-intercept form, so we got to make it look like slope-intercept. We got to get y by itself. So let's subtract 2x. Add 9, and get 3y equals negative 2x plus 9. Again, we want to get y by itself, so we're going to divide by 3, divide everything by 3. And I get y equals negative 2x over 3 plus 3. So now it's in slope-intercept form. You could graph it. First thing I'm always do is find my y-intercept, which is this guy right here. I'm ready to start 0, 3. That's my y-intercept, so right there. Right, keep in mind this is x, right, and this is y. So xy, so you start there, 0, 3. And then next we're going to do the slope. So the slope here is negative 2/3, right? The thing next to the x, the coefficient of the x. So all we're going to do is from that point, our first point there, we're going to go down 2, right, rise over run. In this case, fall. We're going to go down 2, and then we're going to go over 3. Right there. And if you want, you can do it one more time, or a couple more times, depending how you want it. And then you can connect the points. And that's how you graph a line. Right? Just like that. Okay. And before we go on to the next one, let's go back up here. Right? So if I wanted to graph this, right now I really can't graph this. It's an equation, but graphing is not very good. If I actually wanted to graph it, I would put it in slope-intercept form. So I would distribute, and I get negative 2x minus 6, and then I would add the 6 to both sides. Hey, those cancel out. And I get y equals negative 2x. Now, how do I graph that? Simple. Whoops. Sorry. The way I graph that is I just picture this like the plus 0. So this is my y-intercept at 0. And then my slope is 2. That's right. So your slope is negative 2. You always want slope to be a fraction. So put it over 1. So I'm going to go down 2 over 1. Lots of negative slopes today. So I'm going to go down 2 over 1. Connect those. And there's your graph. So something to that effect. Okay, so let's grab this one before I'm done. So 3x plus 7 equals 0. We want to solve for x, so let's minus that 7. Normally we solve for y, right? But there's no y here, so we're just going to have the one variable we have by itself. Divide by 3. X equals negative 7/3. So the way we graph this, we go where x is and go for negative 7/3, which that's the same thing as what? Negative 2 1/3. It's a little past negative 2. We're just going to estimate it there. And I always say follow the tally mark. So normally when you do a tally mark here, you do it like this, right, on the x's. So it's going to go up and down. And that's my graph of x equals negative 7/3, right, vertical line. This has a slope of, this has no slope, right, it's a wall. So And that's why you have no m here, because no slope. A couple key things to remember, right? We did point slope form. That's the thing I used to make an equation. We did slope intercept form. I like to use that to graph. There's also the general form, which is ax plus by plus c. Like you just have everything on one side. We have vertical line. We talked about that earlier. X equals horizontal line. Y equals. And then slope intercept point form and point slope form. Okay, last main thing, parallel and perpendicular lines. So parallel lines are lines that have the same slope. So they never cross. It's something like this, right? They have the exact same slope. Those don't have the exact same slope. These are a little better. So m1 equals m2. So the slopes are the same. Perpendicular slopes are negative reciprocals. So you got to flip the slope and change the sign. So you see here, right? So probably best example, if my slope of 1 was 3, my perpendicular, that's a perpendicular symbol, upside down t, would be flip it and change the sign. So make it 1/3 and then change the sign to a negative. Right? So you always flip it and change the sign. If it's negative, it becomes positive, blah, blah, blah. Perpendicular slopes cross at a 90-degree angle. Those are perpendicular slopes, though. M1, M2. Okay. Let's do a thing real quick and then we're done. We want to do two things here. We want to find the equation of a line that goes through this point and is a parallel to this line here. So you go parallel to that. Then we're going to do the same thing. We want it to be perpendicular. Okay, so for step 1 though, if we want to find the equation of a line, so anytime I want to find the equation of a line, I use point slope form. So we're going to do y minus y1 equals m x minus x1, right? So like that. And we have our x1, y1. They gave it to us. So that's going to be -3, and that's going to be 2. What we do not have is the slope. Now, some people might think it's a thing next to your x, it's your 1. It's not. That only works when we're in point slope form. Sorry, slope intercept form, right? Here's my x. Here's my slope. But it has to be in slope intercept form. We got to get y by itself first. So the first step here is put this in slope intercept form. So we're going to get y by itself. So let's subtract that x from both sides. And we get y equals -x plus 7, which makes our slope -1. So in this case, we want it to be a parallel slope. So we're going to, remember parallel means the exact same slope. They have the same slope, so we're just going to use that slope, -1. And normally I would say we are done, like that. But it does say put it in slope intercept form, right? The slope intercept forms of this. So they want this in slope intercept form, so we're going to simplify a little bit. So the only time I have to do that's when they specifically ask me for that. And then I'm going to add 2 to both sides. And I get y equals -x minus 1. So there we go. Now we're going to do the same thing for the perpendicular one, right? They want an equation of a line. So y minus y1 equals m x minus x1. Again, we have the slope already. Sorry, we have our point already, right? Our x1, y1, done. And now the slope. Again, that's parallels use the same slope. The perpendicular slope, negative reciprocal. So we're going to flip it and change the sign. So we're going to flip it, make it 1/1, and we're going to change the sign. So from a -1 to a +1. So we just get 1. That's our perpendicular slope. Like that. And now they want a slope intercept form, so we're just simplify it just real quickly. Distribute the 1. And then move over that. And here we go. We found the equation of a line that's perpendicular to the line they gave us. And that's it. That's the lesson.